Regularization techniques in AIML models. Linear regression. Description. Regularization techniques for linear regression models help prevent overfitting by penalizing large coefficients. Techniques. Ridge regression L2 regularization. Description. Adds a penalty proportional to the square of the magnitude of coefficients. Lasso regression L1 regularization. Description. Adds a penalty proportional to the absolute value of coefficients, promoting sparsity. Elastic net regression. Description. Combines both L1 and L2 penalties to balance between ridge and lasso regularization. Logistic regression. Description. Regularization techniques for logistic regression models help control model complexity and improve generalization. Techniques. Ridge logistic regression. Description. Applies L2 regularization to logistic regression models. Lasso logistic regression. Description. Applies L1 regularization to logistic regression models. Elastic net logistic regression. Description. Combines L1 and L2 penalties for logistic regression regularization. Decision trees. Description. Regularization techniques for decision trees help prevent overfitting by controlling tree depth and node split criteria. Techniques. Maximum depth limit. Description. Limits the maximum depth of decision trees to prevent them from growing too complex. Minimum samples per leaf. Description. Sets a minimum number of samples required to split a node, reducing overfitting on smaller subsets. Pruning. Description. Post-pruning techniques remove nodes that provide little predictive value to improve tree generalization. Support vector machines SVM. Description. Regularization techniques for SVMs control model complexity by adjusting the penalty for misclassified points and margin size. Techniques. C parameter. Description. Adjusts the regularization parameter C to balance between maximizing margin and minimizing classification errors. Kernel regularization. Description. Regularizes the kernel function to prevent overfitting in nonlinear SVMs. Neural networks. Description. Regularization techniques for neural networks help prevent overfitting by penalizing large weights and promoting simpler models. Techniques. Dropout. Description. Randomly drops neurons during training to reduce reliance on specific neurons and improve generalization. L2 regularization weight decay. Description. Adds a penalty proportional to the square of weights to the loss function. Batch normalization. Description. Normalizes activations in each layer to stabilize learning and improve training speed. Ensemble methods. Description. Regularization techniques for ensemble methods help improve model generalization by combining multiple models. Techniques. Bagging. Description. Constructs multiple models independently and averages their predictions to reduce variance. Boosting. Description. Builds models sequentially, adjusting weights to focus on previously misclassified data points. Stacking. Description. Combines predictions from multiple models using a meta-learner to improve overall performance.